Here is an explanation for the answer to final exam, question number 96 in Electronics Demystified, 2nd edition. If you have the printed book, you'll find it on page 438. We're talking about an RF power amplifier here and how we define the efficiency of an amplifier like that. Well, here's a schematic diagram of a tuned radio frequency power amplifier, just a rather specific design. Notice the component values here, and I've included the caption. It's figure 7-13. If you see capacitances, they are in microfarads if less than 1, and they are in picofarads if greater than 1. So that's 200 picofarads right there. That's 0.01 microfarads there. Resistances are all in ohms, so that's the only one is this one, 47 ohms. Inductances are in microhenries, so these are 2.5 microhenry inductors, and this RFC, radio frequency choke, is 50 microhenries. So now that we know about all of the components and the NPN bipolar transistor, this would be a power transistor, and we can see that it is biased apparently for Class B operation. Class B is in Bravo. So what we have here is a typical radio frequency power amplifier. Well, how do we define the efficiency of such a thing? We define the efficiency as the ratio of the useful signal power output. That's what we get as a useful signal right here at the fundamental frequency, presumably, because that's the only frequency that's going to be useful, unless we want to tune it to a harmonic frequency, to the total DC power input. Now that's not this power input right here. This is the signal power input. The DC power input is the product of the collector current and the power supply voltage. That's what the DC power input is. The efficiency is the ratio of the useful power output to the DC power input. So, for example, if the input DC input power, let's just say as a hypothetical that it's 100 watts. Now that's the product of the collector current in amperes and the power supply voltage in volts. Let's suppose over here at the output we get 54 watts. 54 watts. That is useful radio frequency power output. Then our efficiency would be 54 divided by 100, or 54%. The ratio is 0.54, so it would be 0.54 or 54%. That's a fairly typical efficiency for a Class B radio frequency power amplifier. In any case, the correct answer to this question is E, the ratio of the useful power output to the total DC power input.